Let us look at the topic logarithms. In previous videos, we looked at exponents or indices, and it's important that you review those videos before moving on to logarithms. Now, we want to look, for example, at an exponent or an index, an expression that is in the form of an index, before we actually move on to logarithms. Suppose we have, say, 10 raised to the power of 0. That is equal to 1. Okay, good. Let's say 10 raised to the power of 1. What is that? You remember that would be equal to 10. Suppose we have 10 raised to the power of 2. You get 100. We have 10 to the power of 3. What you get is 1,000. 10 to the power of 4 is 10,000. 10 to the power of 5 is 100,000. All right. And it seems as if you have a shortcut way of getting what 10 raised to the power of is equal to when the index or the power is a whole number. You would say 10 to the 0, there's no 0 there, it's 1 and no 0. 10 to the 1, it is 1 and 1 0. 10 to the power of 2 is 1 and 2 zeros. 10 to the power of 3 is 1 and 3 zeros, and so on and so forth. So in this case, we have indices. The index here is 0, here is 1, 2, 3, 4, 5. And 10 is the base in all cases. Alright? Now, look on your calculator. You will have a button with LOG written on it. And there's another button beside it. With your scientific calculator, you'll see LN. Now, above LOG, you will see 10 to the power of X. So you'd have to press shift or second function to get that, the one above the button. Above ln, you see e to the power of x. We're going to look more closely at these later on, but let me see what my calculator looks like. This is my scientific calculator. Yes, I see there's a LOG and there's an ln. And if I should press shift, or let me see now, with this calculator, on your scientific calculator you would have 10 to the x above it, right? But in this case it would have to be inverse. On your calculator you might have shift or second function, but this calculator that I have on my screen here, you'd have to have the inverse, right, in order to activate the 10 to the x or the e to the x. Now, as I put my cursor on this button, you see it's labeled logarithms, and it is natural logarithms. The full name for LOG is really common logarithms. And we're going to see what these things are in more detail later on. Let's go back to our screen. Suppose we should use our calculator and find log of 0, common logarithm of 0. What do we get? Let's see. Log 0 equal, not log 0, I should say log 1. That's what I wanted. Let's find log of 1. What is log 1? log 1. We get 0. When we found log 1, we got 0 as the answer. Alright, it's 0. What about log of 10? What is log 10 equal to? Log, let's clear the screen. Log of 10 equals 1. So log of 10 is 1. What about log of 100? What is that equal to? Clear the screen. Log 100 equals 2. So the log of 100 is 2. Can you tell the log of 1000 without using the calculator? Well, from looking at these patterns, and the patterns here, log 1 is 0, log 10, that's 1 0 here, and you get 1. Log of 100, you have 2 zeros and the answer is 2. Log of 1000, you have 3 zeros. It seems as if the answer should be 3. Let's see. Let's find the log of 1000 on your calculator. Log 1000 equal, we get 3. It is indeed 3. Now, you can find the log of 10,000. I can bet you it is 4, and the log of 100,000 is going to be 5. Let's just confirm with our calculator before we go on. So it's log 10,000, that's 1 and 4 zeros, and we get 4. And the log of 1 and 5 zeros, which is 100,000, and we get 5. Good. So these are the logarithms of these numbers. Now let's look at these in the index form and these in log form. Now you can see that the base of the indices over here is 10. 10 to the power of 2 is 100. Over here, you have log 100 is 2. You can see that the base of the logarithms here is 10. And that's why your scientific calculator will show 10 to the x above the log button. So let's write down the base in each case. It's 10. Now this is saying, as you can see here, 10 to the 2 is 100. If you use this 10 raised to the power of 2, what do you get? It's going to be 100. Now, we can see a definition of logarithms from looking at what happened here. We can say, what is the logarithm of 100 when the base is 2? Well, the logarithm of 100 is the number that the base 10 must be raised to get 100. Alright? Here, the logarithm of 1000, the base is 10. The logarithm of 1000 is the number that 10 must be raised to get 1,000. So the logarithm of a number is whatever the base of the logarithm must be raised to get that number. Alright? You can have that as a definition of logarithm that I just made up, which seemed to be correct. If the basis of the log is 10 and you must raise 10, the base of the log is 10 and the logarithm of 1,000 is 3, it means you must raise 10 to the power of 3 to get 1,000. You must raise 10 to the power of 3 to get 1,000. Alright? So, that's one definition of logarithm that we can use here. Alright. Now, these on the left in green are in index form. So these expressions are in index form. Because you have 10 raised to the power, or you have 10 to raised to an index. And on the right, these are in log form. You're finding the log of a number. So you can see that. Now, let's erase some of what we have here. We're not going to erase everything. Let us keep the 10 to the power of 3 and the log of 1,000 equal 3 in place. Let's keep that there. Alright. Now, we are going to look at what are called the laws of logarithm. But what we do, you see, let us save that for a different video. So we'll continue from here and look at the laws of logarithms.